Initiating secure system boot. Welcome to the front line of cyber defense, where data integrity meets absolute security. This is SYRAG OS, enterprise hardened.
Welcome everyone, and thanks for joining me for this explainer. Today we're diving into something really cool from our source material. We are looking at the architecture of an operating system that's literally built to fix itself. I mean, think about it. We spend so much of our time in the tech world just constantly patching things, putting out fires, and reacting when systems crash. But what if the infrastructure we use every day actually did that heavy lifting for us? That's the whole idea behind what we're breaking down today, SYRAG OS.
Okay, let's dive into this. What if your software could just detect and fix its own errors? And I'm not talking about popping up an obscure error code that you have to decipher 3 hours later. Now, imagine a system that spots a fault, actively figures out the solution, and then seamlessly bakes that fix right into its very next release. You know, an environment where you aren't perpetually playing catch-up with bugs, because the system itself is out there hunting them down automatically.
Now, I know what you're thinking. Come on, this sounds like a sci-fi movie pitch. Well, welcome to July 2026. This explainer is actually grounded in an article published by Mauricio Rosari on that exact date. And Rosari is straight to the point. This self-healing technology, it's not science fiction anymore. They actually built the thing. SYRAG is out there right now, running on a small fleet of machines in the real world. So this isn't some theoretical white paper we're talking about. It's a live, functioning reality that is fundamentally shifting how software maintains itself.
All right, let's get into section 1, the self-healing OS. So how does a machine even know it's broken if a human isn't, banging on a keyboard and screaming at a frozen screen? It all comes down to how it monitors its own baseline health. And the absolute heartbeat of this whole ecosystem is the number 5. See, SYRAG OS operates on this incredibly strict, critical 5-minute interval. Every 5 minutes, like clockwork, it wakes up and runs a highly disciplined health check. And it's not just pinging to see if the server is on. It's running actual, heavy-duty compliance checks against 5 different rigorous security frameworks. To put that into perspective, that means 288 times a day this operating system is actively interrogating itself, demanding to know, hey, am I still secure? Am I compliant? Am I running right?
During that 5-minute window, the system follows a super deterministic step-by-step process. First up, it runs a quick, lightweight scan of all its module health endpoints. Then, step 2, it parses through its own log files, but it's specifically hunting for error patterns. It's not waiting around for a catastrophic crash, it's looking for those tiny breadcrumbs that lead up to one. Finally, step 3, it executes those compliance checks we just talked about. It is relentless. It completely flips IT from being this reactive, wait-until-it-breaks chore into a proactive, active hunt for anomalies.
But here is where it gets really interesting. What happens the exact second it actually finds something wrong? In a normal system, an error is usually just some chaotic string of text dumped into a giant, messy log file, right? Well, in SYRAG OS, every single anomaly it detects is instantly transformed into structured data. Boom. It automatically gets a unique ID, its exact severity level is determined, it gets stamped with the precise time, and then it's registered into a single source of truth. The error goes from being a panic-inducing mystery to a clean, organized, manageable profile in milliseconds.
Which brings us to section 2, the fix and decentralization. Because honestly, finding the bug, that's only half the battle. How does the OS actually solve the problem it just so perfectly boxed up? Well, when a fix is proposed and verified, it isn't just slapped on as some quick, messy patch. The solution is meticulously packaged into a specific versioned bundle. And this brilliantly illustrates their security mindset, because that bundle is then signed with dual cryptographic keys. This is absolutely crucial to guarantee what experts call non-repudiation. Simply put, it gives us absolute mathematical certainty about exactly where this fix came from, and proves that nobody tampered with it. The integrity of the fix is locked in before it ever goes anywhere near deployment.
Okay, so once that fix is cryptographically locked down, it gets published to IPFS, the Interplanetary File System. Now this is a decentralized network, and this is exactly where the magic happens. By publishing the IPFS, other machines, the other nodes running this OS, can independently discover the fix. They verify those cryptographic keys for themselves, and then they just apply the fix automatically. No human copying and pasting code. No manual updates, and the best part, the most impactful fixes get seamlessly baked straight into the next ISO release. So the whole operating system image just gets downloaded straight from IPFS, already fixed.
Just think about the sheer power of this principle. One node discovers a solution, and every single node benefits. That is the compounding power of decentralized distribution. If one random machine in the fleet hits a weird, rare error, structures it, and gets a verified fix packaged. Well, that one machine just effectively immunized the entire rest of the fleet. The whole network literally learns from one machine's localized discovery. When you compare that to how siloed traditional IT infrastructure is today, the efficiency is just off the charts.
Let's move on to Section 3, the human in the loop.
Now, before we get completely carried away picturing some fully autonomous, Skynet-level AI software, there is a major plot twist here. Maurizio Rosari very intentionally calls this system semi-automatic. And here's why. Sure, fully automated sounds super efficient on paper, but the risk? It could rapidly blast a bad fix everywhere across that decentralized network. So instead, SYRAG OS relies on a semi-automatic model. The system detects the bug, classifies it, packages it, and distributes it totally on its own. But the actual implementation of that fix? No way. That strictly requires a human safeguard. A real person has to provide the final cryptographic sign-off.
So the crucial point is this. A bad fix propagated to many nodes is actually way, way worse than the original error ever was. Just imagine that amazing compounding power of decentralization we were just raving about, but applying it to a catastrophic mistake. It would literally take down the entire fleet in a matter of seconds. And that's exactly why SYRAG deliberately hits the brakes right before the final step. It prioritizes system integrity over pure unchecked speed. It's proof that maybe the future of infrastructure isn't about removing humans entirely, but rather elevating where the human actually interacts with the system.
All right, our final stop, Section 4, Evolution Through Errors.
This brings us to a really profound shift in how we even think about software maintenance. Maurizio Rosari notes, and I love this quote, "Errors are not noise to be silenced. They are structured data, the most valuable source of system intelligence." That completely flips the traditional view of software bugs on its head, doesn't it? Normally, we see bugs as massive failures, right? Annoyances, red flashing lights that we want to just hide or bury as fast as possible. But Rosari is arguing that these errors are actually the most valuable intelligence your system can possibly generate. Once you structure an error, it stops being a problem and becomes a roadmap for evolution.
So, to wrap this all up, let's look at the SYRAG difference. By marrying those deterministic 5-minute detection cycles with the massive decentralized distribution power of IPFS, this system literally learns from its mistakes. It takes those structured errors, turns them into verified fixes, shares that newly found knowledge across every single node, and organically evolves with every new ISO release. It is an operating system that gets objectively better, far more resilient, and much more secure every single time it runs.
Which leaves us with this final, incredibly thought-provoking question to chew on. If our systems can be designed to learn so flawlessly from their mistakes, are we ready to learn from ours? SYRAG OS shows us this incredible future where technology doesn't just work for us, it evolves right alongside us, still relying on our wisdom for that final sign-off. It's honestly a beautiful model of human-machine collaboration. Thank you so much for exploring this source material with me today. Keep asking questions, keep learning, and I'll catch you in the next explainer.